Hello everyone and welcome to another Math Tutor Edu's math content video. In this video, I'm going to discuss the derivatives of logarithmic functions. Okay, so for instance, if you have a function of ln x, or also known as a natural logarithm x, so for example d over dx in a bracket natural logarithm x, or for convenience I'm going to say it as ln x. Okay, so when you differentiate this with respect to x, so we're going to get 1 over x. Okay, provided that your condition, your x need to be more than 0. Okay, so this is one of the formula that you're going to apply in order to solve the derivatives of logarithmic function. Okay, so let me box this formula. Okay, we're done with the first one. Okay, let us move on to the second formula. Okay, for the second formula, we're going to proceed with the logarithmic formula, which is the log function. Okay, for instance, if you are required to differentiate a log x with the base b, okay, so and you need to differentiate with respect to x. Okay, so from here, when you differentiate this, you should be getting 1 over x times with the natural logarithm b. Okay, the base of the log will be over here, the x will be over here. Okay guys, okay, so from here, when you differentiate log x with respect to the base b, so when you differentiate this, you will be getting 1 over x times with natural logarithm b or ln b. Okay, so from here, let me box this formula as well. Okay, so these are the two basic formulas that you need to know. Okay, enough with the formula explanation. Let us straight away jump to the exercise, because that's what I usually prefer. Okay, less theory and then more towards the practice. Okay, so let us begin our practice now. Okay, so from here, let us start with the example. Okay, let us start with the example number 1. Let us start with the easy one first. Okay, so given that your y is equals to, for instance, you have a cos, okay, and then in a bracket you have natural logarithm x. Okay, so let us start with consider with the easy one. Okay, so from here, now you have a trigonometric function and a natural logarithm function. Okay, so from here, this is actually a chain rule, guys. Consider as a chain rule. So how are we going to solve this? Okay, so let me show you. So let us differentiate this with respect to x. So from here, dy over dx, so will be equals to, okay, let us start to differentiate the cos first. Okay, remember that when you differentiate cos, you'll be getting negative sign. Okay, so from here, let us differentiate the cos first. So from here, when you differentiate the cos, you get this negative sign times with ln x. Okay, so you're done with the cos. Let us proceed with the inside value. Okay, times with, okay, remember guys, just now we have explained that when you differentiate natural logarithm x, you should be getting 1 over x. So from here, ln x, you differentiate, you get 1 over x. Okay, so from here, you should be getting your dy over dx will be equals to negative sine ln x divided with x. Okay, it's considered to be an easy example, guys. Okay, let me start with the easy one. Okay, so this is considered to be an easy example. So from here, I will slowly move on to the complicated one. Okay, so far so good. Okay, so from here, let us proceed to the similar example. Okay, let's say you have y is equals to sine square natural logarithm x or ln x. Okay, so in this case, to solve, we are going to use y prime, okay, for the explanation purpose, guys. But if you wanted to use dy over dx also can, okay, for the derivative. Okay, so what we're going to do is we're going to start by solving the sine first, the outside one, and then we're going to focus with the inside one. Okay, so that's how the chain rule actually works, guys. Okay, so from here your y prime is actually equals to, okay, so we're going to differentiate this. So from here it's going to be 2 sine ln x, okay, and then times with the sign differentiation. So from here get is cos ln x, okay, and then times with the differentiation of this ln x itself, which in this case is 1 over x. Okay, I hope you guys are clear about this. So from here you get your y prime is equals to 2 sine ln x cos ln x over x. Okay, so if you remember 2 sine ln x cos ln x, so we can literally simplify this as a double angle formula, where sine 2a is equals to 2 sine a cos a. So we can actually simplify this as sine 2a itself, but if you decided to leave your answer in this way also can, but I'll recommend you to simplify this equation. Okay, so from here our answer will be y prime is equals to sine 2 in a bracket natural logarithm x divided with x. Okay, so let me underline the solution. Okay guys, so just wanted to inform you early that in my previous recording I've made some mistakes. Okay, however, so this is the final answer, where your y prime should be equal to sine 2 ln x divided with x. Okay, so let me proceed over here. Okay, for the example 3 is going to be slightly complicated. Okay, so from here let's say you have a function of y is equals to ln x square plus with 1. Okay, so from here let us perform the differentiation. Okay, in this case we're going to use the dy over dx. So from here the dy over dx, okay, is equals to, okay, let us start with the natural logarithm itself. Okay, so from here when you differentiate ln x you get 1 over x. So from here ln x squared plus 1 will be 1 over x squared plus 1. Okay, so we already done with the natural logarithm. Let us start to solve the inside function. Okay, so when we differentiate the inside function, so you will be getting 2x, but for the working purpose let me just show the extra step. Okay, d over dx x squared plus 1. Okay, so from here you get your dy over dx is equals to 1 over x squared plus 1 times with 2x. Okay, so from here you get your dy over dx is equal to 2x over x squared plus 1. Okay, so let me underline the solution for the question 3. Okay, so let us move on to the example number 4. Okay, is going to get even more complicated. Okay. So from here, let's say you have a function of y is equals to natural logarithm x squared sine x, okay, and then you divide with square root, oops, you know what, okay, square root one plus x, okay, in a bracket. Okay, so now here is the part that is going to get complicated. So what we are going to do now is, okay, we are going to break this logarithm into the part by part. Okay, remember guys, the law of logarithm is applicable to law of natural logarithm. They are almost similar. Okay, so from here you have the combination of a multiplication and the division. Okay, if you try to decide to do differentiation by breaking one by one, let's say for example you're going to start with the natural logarithm, which is 1 over x square sine x, and then divide with 1 over square root x. Okay, if you try to decide to do one by one by doing the chain reaction, start with the natural logarithm and then you try to do the division rule, and then within here you have trigonometric function, is going to be tedious. Okay, so what you can do actually is you try to break this using the natural logarithm rule, guys. Okay, so from here what we can do is, so from here y is equals to, okay, this natural logarithm, so here you have x square times with sine x, so x square sine x, so we can break it as ln x square plus with ln sine x. So from here y is equals to ln x square plus with ln sine x, because when you if you want to combine these two natural logarithms together, it will be multiplication. Okay guys, so since here you have the division, so you need to minus ln in a bracket square root 1 plus x. Okay, but remember guys, square root 1 plus x you can also write as in a bracket 1 plus x to the power of 1 over 2. Okay, so from here let us do the step-by-step working. Okay, so this 2 power we can bring it to the front. Okay, y is equals to 2 ln x plus with ln sine x, okay, minus with 1 over 2 ln 1 plus x. Okay, so from here, once you have already done everything, let us perform the differentiation of this whole equation. So from here d over dx, okay, in a bracket, so let me just copy and paste this whole equation. Okay, so let us perform the differentiation one by one. Okay, so from here differentiation for 2 ln x, so from here you'll be getting 2 over x. Okay, so differentiation for ln sine x will be, okay, plus with 1 over sine x. Okay, and then remember that you need to differentiate the sine x as well. In this case will be cos x. Okay, make sure don't make any mistake over here guys, be careful. Okay, so from here 1 over 2 ln 1 over x, so it will be 1 over 2 in a bracket 1 plus x, close bracket. Okay, let me write it properly. Okay, So from here, let us expand the equation. So from here, 2 over x, okay, and then plus with cos x over sin x, okay, and then minus with 1 over 2 plus with 2x. Okay, so we are very close to our final answer for example number 4. So from here, our answer for example 4 will be 2 over x plus with, okay, remember guys, cos x over sin x, we can write it as cotangent x, okay, minus 1 over 2 plus 2x. So this is your answer for example number 4. Okay, so I hope you guys can able to catch me up, follow with me. Okay, so far so good. So we have slowly increased the complexity of the logarithmic function. Okay, so let us proceed to our one last example for today, so which is the example number 5. Okay, so given that your y is equals to x squared, okay, and then times with cube root, okay, let me write it properly, okay, cube root 7x minus 14, okay, and then divide with 1 plus x squared to the power of 4. Okay, so if you try to solve this question using the products rule, or you want to use the chains rule, is going to be extremely tedious. It's going to be tedious, guys, okay, because as you can see here itself is already complex, and then if you decided to do the steps using the chains rule, is going to be very long. Okay, so what you can actually do in order to solve this type of question is actually you can try to ln both sides. Okay, try to use the natural logarithm both sides. So we're going to ln both sides in this case. Okay, so from here it will be natural logarithm y is equals to natural logarithm, okay, in a bracket. Okay, so let me just copy paste the equation. Okay, so from here, for the next step, what I'm going to do is, okay, so I'm going to break down this complex natural logarithm into addition and subtraction of a natural logarithm. So from here, ln y will be ln x square plus with ln, okay, 7x minus 14 to the power of 1 over 3. Okay, y in this case, okay, originally it was cube root. Okay, cube root you can also write in this form as well, which is 7x minus 14 to the power of 1 over 3, guys. Okay, just for your information, in case if you forget, we can also write in this form as well. Okay, just want to recall in case you forget. Okay, so from here, the multiplication you can separate it back through addition. For the division you can separate through subtraction. Okay, so from here, so it will be minus natural logarithm 1 plus x squared to the power of 4. Okay, so from here let us continue our working. So from here, natural logarithm y will be equals to, okay, this power we can bring it to the front, so it will be 2 ln x. Okay, so by the way, let me remind you, this is not differentiation yet, this is just the logarithmic rule, guys. It's a law of ln. Okay, the power you can bring it to the front. We haven't performed the differentiation yet. Okay, let me just remind again. Okay, it's part of the natural logarithmic rule. So from here, ln y is equals to 2 ln x plus with 1 over 3 natural logarithm 7x minus 14, okay, minus with, okay, so let me just continue at down here, minus with 4 natural logarithm 1 plus x squared. Okay, so from here we're going to differentiate both sides. Okay, so what we're going to do is it's going to be a combination of implicit differentiation as well, guys. Okay, technically what we're going to do here is, okay, so from here we start to differentiate at the left hand side. So from here, ln y you differentiate will be 1 over y, okay, times with dy over dx. Okay, remember guys, whenever you perform the implicit differentiation, always remember that you need to times with dy over dx, okay, equals to 2 ln x. So you differentiate, you get 2 over x, okay, because ln x you differentiate, you get 1 over x, guys. Okay, and then plus with, okay, 1 over 3 times with ln 7x minus 14. Okay, so from here 1 over 3, okay, divide with 7x minus 14, okay, and then times with the differentiation inside bracket, in this case is 7. Okay, so from here we can write this equation as 7 over 3 divide with 7x minus 14. Okay, so from here you can write like this, or you can wish to times the 3 at the denominator also can. Okay, so from here, so let us differentiate this. So from here, minus with 4 divide with 1 plus with x squared, okay, and then times the differentiation inside the bracket, so in this case is 2x. Okay, so from here let us proceed our working. So from here 1 over y times with dy over dx is equals to 2 over x plus with 7 over 3 divide with 7x minus 14, okay, and then minus with 8x divide with 1 plus with x squared. Okay, so from here we are very close to our final step. Okay, we have just a few steps left. Okay, so from here what we're going to do is, okay, we want to eliminate this 1 over y, guys. So what you're going to do, we're going to times y both side. Okay, times y both side of equation. So from here you only left with dy over dx is equals to y times with 2 over x plus with 7 over 3, okay, in a bracket 7x minus 14 minus minus with 8x divide with 1 plus with x squared, okay, close bracket. Okay, so here you have y. However, in the earlier of a question we have an expression that y is actually equals to x squared times with cube root of 7x minus 14 divided with 1 plus x squared to the power of 4. Okay, so this is the expression, guys. So what you're going to do this is you're going to copy this. Okay, so let me just copy this whole equation. So from here dy over dx will be equals to, so let me just paste it over here. So the y I remove, Okay, since your y is actually equals to this x square times with cube root of 7x minus 14 divide with 1 plus x squared to the power of 4. So we're going to replace this, okay, and then times with this equation. Okay, times with, okay, let me just write a dot over here. Okay, let me just scroll it over here. Okay, okay, you can leave your answer in this way. But some of you guys might ask me, so why you have the 7/3 in this way? So can you just make it better? Yes, you can make it better. You can leave it like this, or if you want to wish to make it 7/21x minus 42 also can. The 3 you times it down over here, where in this case 7/3 will become 7/3 times it 1/7x minus 14. So the denominator 3 will be times directly over here. So from here you get 7/21x minus 42. Okay, also can. Okay, it is up to the students, guys. Okay, it's actually up to you. You can leave your answer in this way, or you want to wish to simplify also can. Okay, so from here let us underline the solution, the complete solution. Okay, so let me scroll this up. Oops. Okay, so that is all for the step-by-step working and explanation for the derivatives of logarithmic functions lecture video. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming advanced mathematics video in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.